Infinite sequence and finite sequence. First of all, what is a sequence? Sequence is a list of numbers with some patterns. So there are infinite sequence and finite sequence. So for infinite sequence, we start at the first term. So that is A1. A1 is the first number in that sequence, and then A2, A3, A4, A5, and then all the way to AN. So since this is infinite, and we will just keep on going. So just keep on going forever. And then for finite sequence, we start at the first term, A1, and then A2, A3, A4, and then we go all the way up to AN. So since the number of elements in this sequence is countable, then we call this a finite sequence. So there are a total of n terms. So if you have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so you can call this a finite sequence. There are 10 terms in this sequence. So let's do some examples. So the first example I have is we have 2, 4, 6, 8, 10, 12, 14. And then do you see this? I have a comma and then dot, 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 dot. So that is a infinite sequence. So the first term is 2. So I call that n equals to 1. 1 means the first term. 2 means the second term, 3 means the third term, 4 is the fourth term, 5 is the fifth term, so on and so forth. So for infinite sequence, what about AN? AN is in general. What is the pattern? So what is the pattern in general? So we have 2, 4, 6, 8, 10. Do you see the pattern that the 2 is double of 1? 4 is the double of 2, 6 is the double of 3, 8 is the double of 4, 10 is the double of 5, 12 is the double of 6, and then 14 is the double of 7. So as we move on, in general, the pattern is you have 2 times the number of terms. So the first term, when n is 1, you have 2. When n is 1, that A1 is equals to 2. So when n is equals to 1, so we have A1, that is 2 times 1, which is equals to 2. All right. How about the next one? The next one, we have 3, 5, 7, 9, 11, 13, and then we stop at 13. So the total number of terms in this sequence is, you can say the total number of elements is countable. So we call this a finite sequence. How many terms, how many numbers are there? There are 6, right? The first number is 3, second number is 5, third number is 7, so on and so forth. And then what is the sequence? The sequence is, it looks like, can we just do, so the difference is 2, right? 3 to 5, 5 to 7, 7 to 9, 9 to 11, you add 2. Can we just do a n plus 1? Can we do that? Can we do a n plus 1? Is this correct? When n is equals to 1, no, that is not right. If you just do n plus 1, when n is 1, you have a 3. When n is 2, you have when n is 1, you have a 2. When n is 2, you have a 3. So that doesn't sound right. So how about we double up the n first? So when n is equals to 1, we have a 3. When n is equals to 2, we have a 5. So it looks like an equals to 2n plus 1 works. So this is the pattern of the second sequence. And then how about the yellow one? The yellow one, we have -2, 3, -4, 5, -6, 7, -8, and 9. Alright, so this one we have a dot dot dot, so that is an infinite sequence. And then what is the pattern in general? So first of all, do you see that the negative sign alternates, right? So negative and then positive and then negative and then positive. So this one I am going to start with a -1 and then raise to the n to see if that works. When n is equals to 1, we have negative. When n is equals to 2, we have positive. N equals to 3, we have negative. So when you do -1 raised to the n, when n is odd, then there is a negative. So which is true, right? 1, n equals to 3, n equals to 5, n equals to 7. And then how about the numbers? The numbers, so without looking at the negative, we have just n plus 1, n plus 1, n plus 1, n plus 1. So I am going to make that multiply n plus 1. So that is the pattern of this infinite sequence. And then the next one, we have a finite sequence. So finite sequence, we have a -2, 1, 4, 7, 10, 13. Okay, so stop at 13, then this is a finite. And then what about the What about the pattern? So in general, can we just do n? That doesn't look right at all. How about 3n? That doesn't look right at all, because when n is equals to 2, we have a 6. When n is equals to 3, we have a 9. So it looks like we are 2 units more than the actual numbers. Then we will just do a minus 2. So now that will work. 3n minus 2. That is the pattern of this finite sequence. Okay, and the next one we have a recursive sequence. Recursive sequence is provide the first few terms. So we have a of k that is equals to 3a of k minus 1 plus 2. When a is equals to 1, I want you to find a2, a3, a4, and a5. So recursive sequence. Provide the first few terms for me. Okay. Let's do that. So we match the color first. We already have the first term. So that term is k equals to 1, right? And then when k is equals to 2, what do we have? We have a of 2, which is equals to 3 times a of 2 minus 1, and then plus 2. Then this is based on the first term. We have 3 times a plus 2. That is equals to 26. And then when k is equals to 3, we have a of 3 equals to 3 times a of 2 plus 2. Then this is 3. A of 2, we just got that. That is 26 plus 2. This is equals to 80. And then when k is equals to 4, we have a of 4 equals to 3 times a4 minus 1 plus 2. This is a 3 times a3, which is 80, and then plus 2. 240 plus 2 is 242. And then when k is equals to 5, we have a of 5. This is 3 times 5 minus 1, and then plus 2. So we have 3. We have 3. A of 4 is 242, and then plus 2. That is equals to 728. All right, so these are the first 5 terms of the recursive sequence. All right, so moving on, we have a very famous sequence called Fibonacci sequence. So Fibonacci sequence is the next term, is the sum of the 2 preceding terms. So here is an example. So let's say we have 1 comma 1. And then what about the next term? The next term is the sum of the 2 preceding terms, so which is 2, and then 1 plus 2. 2 plus 3, 3 plus 5, 5 plus 8, 8 plus 13, and then 13 plus 21, that is 34, so on and so forth. So this is a Fibonacci sequence. So this one, 1 plus 1 is equals to 2, 2 plus 2 is equals to 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 8 plus 3, 21, 21 plus 13 equals to 34, so on and so forth. So for Fibonacci sequence, let's do write more for that. So the first term. Oh, by the way, for Fibonacci sequence, do you remember the an, the subscript n? Looks like n always start at 1, right? But that is not true. Sometimes n can start at 0. So this one, we can call this the 0th term, the first term, the second term, the third term, the fourth term, and then the fifth term, and then the sixth term, and then the seventh term, and then the eighth term. 0, 1, 2, 3, 4, 5, 6, 7, 8. So n can start at 0. So this one, a of 0, which is the very first term, and then a of 1, that is also equals to 1, and then we have a of 2 equals to a of 0 plus a of 1, right? It's the sum of the 2 preceding term. So in general, for a of n, this is equals to, you add the 2 preceding term. So the first preceding term is n minus 1, the second preceding term is n minus 2. So this is the pattern of Fibonacci sequence. All right, and then when you learn sequence, later on we will discuss series as well. You will have to know factorial. Factorial is commonly used in sequence. So when you study English, the sign, this is called exclamation mark, right? This is called exclamation mark, but please don't say the word exclamation mark in math. In math, we call this factorial. which is the exclamation mark. So n factorial is equals to n times n minus 1 times n minus 2 times n minus 3, and then all the way to 3, 2, 1, but you do not multiply 0, because once you multiply 0, everything becomes 0. And there is a special case, 0 factorial is equals to 1. So let's do some basic steps. 1 factorial is just equals to 1. Did I match the color? No. This should be the right color. So this is 1, 2 factorial 2 times 1, and then 3 factorial 3 times 2 times 1, and then 4 factorial 4 times 3 times 2 times 1, and then 5 factorial 5 times 4 times 3 times 2 times 1, that is equals to 120. How about this n factorial divided by n minus 2 factorial? So this one will be what? Let's look at the top. So that will be n times 1 smaller than that, which is n minus 1, 1 smaller than that, n minus 1 minus 1, then that will be n minus 2. So as we keep on going, we will have n minus 3 and then n minus 4, right? But do you see that in the denominator, we have n minus 2 factorial? So I am going to take a few steps back, and then I will just stop at n minus 2, and then I will just place a factorial in here. So that is like placing a stop sign, so I don't need to keep on writing. And then divided by n minus 2 factorial. As a result, I can get rid of these 2, and then the answer is equals to n times n minus 1. So that's how you do the simplification. For 9 factorial, here is what we can do. So this is a 9, 8, 7, and then 6, 5, 4, 3, 2, 1, right? But you don't need to write all of those. You can just go back to 6 and then stop at 6, replace a 6 factorial, because we are dividing by 6 factorial. And then regarding the 2 factorial, that is just 2 times 1. As a result, we can get rid of the 6 factorial. So this one, what is that equal to? That one is equals to 9 times 7. That is 9 times 8 times 7, that is 504 divided by 2, which is equals to 252. All right, how about this? 5 factorial divided by 3 factorial. Let's draw a line. So that is 5 times 4 times 3. You can write 2 times 1, but we don't do that. We just stop at 3 factorial because the denominator has a 3 factorial. And then the n plus 2, we start at n plus 2, and then 1 less than that. 2 minus 1 is 1. And then 1 less than that, 1 minus 1 is 0. So we have an n, but we stop there. So that is n factorial. And then we divide it by n factorial. We get rid of these 2, we get rid of that, so that is equals to 20 times n plus 2 times n plus 1. That's it. How about the last one? The last one, what can you do for the top? The top is 2n plus 1, 1 less than that, and then 1 less than that, and then 1 less than that. Now we reach to 2n minus 2. Factorial, and then the denominator, you have 2n minus 2 factorial. Perfect. Get rid of them, and then whatever left there is your answer. All right, so this is the end of this video. If you like the way I give the introduction to sequence, give me a thumbs up, give my channel a subscribe. Trust me, it is worthwhile coming back to visit for more math content. As always, I will meet you all in the next video. Signing out. Take care.